Welcome back, students. We are continuing with the AKTU video lectures on different modules on different courses. I am here to teach something about the geotechnical engineering, a subject related to civil engineering. So, we were talking about the consolidation CV, okay, coefficient of consolidation in the last class. Today, we will go in detail about what is the time factor and all. Okay. So, let us start our class. Also, we will be studying about the Terzaghi's theory today. So, let us start. What is Terzaghi's theory? You know that he has given a lot of theories, but from about the consolidation, okay, he has consolidation. Sorry. He has given a 1D theory, okay, one dimensional theory, because if you remember last class we have already discussed that he has taken it to be something like this, okay, that the stress comes out like this only from one direction, or the water which is to be released will be going out from the top and bottom layer only, not from the sidewise, okay, not from sidewise. Hence, it is a 1D theory, consolidation 1D theory. Now, let us see what are different quantities and things used by him. First of all, relates the following three quantities: the excess pore pressure, okay, which is UE from now. Previously, we were talking it to be as delta U. Then the depth below the top of the clay layer. Then time measured from the start of the consolidation, that is the instant at which the total stress increment was applied. So, these three means we have three parameters U, E and T and H, these three, okay. The calculation or the derivation part is very long, you do not need that. So, mainly we will be concerning about this formula, okay. Sometimes this is also asked in different competitive exams also. So, this formula, remember, del U E upon del T with respect to time, okay, will give you the value C V, and here you will be having double, okay, means this will be double differentiation. This is a partial differentiation of this pore water pressure or excess pore water pressure with respect to time, okay, with respect to time. And in this place we will be having the same, but with respect to H, or you can say Z, whatever you like, okay. Let us say Z only, otherwise you will get confused here. So, you can say it is Z only, depth, okay. So, in this part, what is this? If we write, this will be the partial differentiation of U E, or which is this, what is this? This is excess pore pressure with respect to what? Time, okay. We can also say this is first order partial differentiation of U E or excess pore water pressure or pore pressure with respect to time, which is del U E by del T, okay. Let me remove this one as well. Now, it is clear, okay. So, this was one part, and what is this? This CV you already know, this is the coefficient of consolidation, okay. And what is this? This is second order partial differentiation of U E, which is the excess pore pressure, but this time with respect to Z, What is z? Z is the depth only. Okay. So, we can write here depth. So, this is the actual formula which was given by Terzaghi after his rigorous experiments. Now, this units meter square per day and meter square per year, these are the units for CV. Okay. So, CV is the coefficient of consolidation which we have already studied. Now, the value of CD, okay, also can be said to be, value of CV can also be written as K upon gamma W into MV, or we can say K can be said to be CV MV gamma W. Okay. Now, here what are these parameters? What is K? K is the coefficient of permeability. Coefficient of permeability. Okay. K is the coefficient of permeability which we have already studied. Okay. So, this is the same K. CV we have already discussed, MV you know already, even though I will write it here. It is the coefficient of volume compressibility. Volume compressibility. Okay. And what is gamma W? This is obviously unit weight of water. So, these are all the parameters which are used in the equation. So, from this also we can find the value of CV. This is also an important formula. Okay. This one. So, this was the term which was used by, this CV term was first used by Terzaghi only. Okay. Then later on different formulas were used and methods were used to find out the value of CV. You know, yesterday we discussed the experimental method or graphical methods to find out this CV. Okay. Graphical methods we discussed in the last slide. Okay. So, now you can also find out it by the analytical method or the formulas. So, this is one of them. Okay. Then solution to the consolidation equation. This is the consolidation equation just now I told you. Okay. Now, let us see other different things. First of all, if we have a clay soil layer of depth 2D draining at both sides, as happens in case of consolidometer test, then the boundary conditions available will be, first of all, now let us see what is this double drainage and single drainage and all. If we have something like this, okay, first of all let me check. Okay, you can find it here only. This is actually the concept of drainage. Okay, here you will be finding it. The length of the longest drainage path is shown in the figure below. Now, what is this D? Okay, this D, or you can say Z. Okay, this Z depth, this is actually length of longest drainage path. Okay, length of longest drainage path. Now, in this case we have two cases here, you can see one is having an impermeable membrane here and only permeable in the upper part, and in second both of them are permeable. So, what will happen to this Z, or what will be the value of this Z? Z is called the length of longest drainage path. So, in the first case, if water is somewhere here, okay, somewhere here, water is somewhere here, then how much path it will have to travel in order to get out from this soil mass? Just try to understand this, how much the path this water molecules will have to travel in order to get out of this soil mass, because this part is already impermeable. Okay. So, it will won't be able to get out from this part. So, only left option is which one? This one. It will have to travel all the way like this. Okay, have to travel like this only to hold this D or H will be travelled in order to get out from this. Okay. it will have to travel the whole part. We erase it all. So, in this case what happens, d becomes equals to h, which is the z also. Okay. So, the length of longest drainage path will be d itself, the whole part. But in this case, let us see, both the parts are permeable. So, what will happen? In this case, the particle which is here, okay, will immediately go drain out. Okay. The particle which is here will be draining out from the shortest path. Okay. So, it will drain out from here, somewhere here. If the particle is there, then it will drain out from this part, okay, like this. Maximum drainage or time taken by these particles, okay, maximum time will be taken by the particles which are in this middle area, okay, middle of this whole area arrangement. These particles will go from here and these particles will go from here, okay, because since both of the layers are permeable. So, they have the choice to go like this as well and they have the choice to go like this as well. Okay. So, in this case, the longest path travelled by the particle to move out will be how much? Small d, okay, or we can say h by 2. If this whole specimen is h, then z now will become h by 2, which I already told you in the last slide, okay, which where we were doing the calculating the value of CV, and I told you that there is a 2 centimeter thickness of the specimen, and we took 2 centimeter by 2, that is 1 centimeter is equal to the value of d. Okay. So, the same concept, this is the main concept. And why we used double drainage only? Because in consolidation test, okay, in consolidation test what happens, we are having this arrangement, not this one, we are having this arrangement there in that test apparatus. So, the drainage path becomes this. Okay. This was the concept of the drainage condition or the drainage path, or we can say Z, which is also sometimes called the depth. It will be equal to depth when there is the single drainage. You can see both are equal. It will be equal to depth, let me write it, Z will be equal to depth when single drainage condition, single drainage condition, and when will be it equal to the depth by 2 in double drainage condition. Okay. So, these two are the concepts which we had to learn about Z. Now, what is it written here? A layer from which both upper and lower boundaries are permeable or free draining is called open layer. So, this is called an open layer. Okay. This is just a terminology, not much used, and a layer from which only one boundary is permeable is known as half closed layer. This is called as half closed layer. This is half closed and this is open layer. Okay. So, this was the concept of Z. Now, let us move back to the place we were dealing with the. Okay. So, here now you have understood what is Z. Okay. Now, both ends are open, means what will happen to 2D, it will become D. Okay. D will be equal to Z. Why? Because Z will become 2D by 2, which is D. Okay. Because it is double drainage. So, let that apart. Now, let us see what are the boundary conditions which will be available to us. Okay. So, you know about the boundary condition. If this is the layer, the drainage is here also, let us say here was sand. Okay. In sand the drainage can be made. Here also it was sand, let us say, and this may be clay. Okay. This is clay, these are sands only. So, just think of it, the pore pressure here, okay, the pore pressure here and the pore pressure here. this is of height 2d. Okay. Here from here we will move down, then we can say that here z is 0, here z is 2d. Okay. So, at this point what will be the pore water pressure in this point at 0? Okay. What will be the pore pressure? It will be equal to 0. Why? It will be equal to 0. U will be equal to 0. Why? Because as soon as some pressure tries to develop here, pore pressure, it will get out, because it is already permeable here. So, no pressure or pore pressure can be developed in this part, in this layer, because as soon as the development of the pore pressure starts, it will ooze out. So, U becomes 0 in this part. And what about this part? Same concept, because here also we have sand. So, what will happen? The particles which are here, or the water molecules which are here, if they try to exert the pore pressure, what will happen? They will get out from here and no pressure will be exerted. So, U also will be 0 here. So, this is the condition, at 0 also 0 and at 2d also 0. Okay. This was the concept. After that, this is solved through a rigorous process. You need not memorize or mug up all this. Mainly the outcome is this, you have to remember this one. This formula, as I already told you, Tv is equals to Cv into T upon d square. This is the final formula. Okay. And what are here? I already have told you, this is the time factor, d the longest path, okay, which the water molecule has to move on. Okay. Then what is Cv? Cv is the coefficient of consolidation, and what is T? T is the time required for any u degree or u percentage of consolidation. Okay. Like we will be doing in forthcoming questions as well. This we have already discussed. Now, let us see the determination of coefficient of consolidation. We have already nearly covered all these. Let us just see through what are there. Okay. Time is directly proportional to d square. How this came? Just now we saw that Cv is equals to, or let us write from Tb only, you will get confused. Tv is equals to Cv into T upon d square. So, T into Cv is equals to Tv into d square. So, only looking at their relation, T will be directly proportional to d square. Okay. Is it fine? So, once we change the drainage condition, accordingly the time will change. I think you understand. If single drainage, then what will happen to T? T for single drainage, this will be d only. Okay, this will be d only, proportionally. While if we consider for double drainage, if double drainage, in case of double drainage, what will happen? In case of double drainage, you know, this will change. Why? D by 2 will occur. So, this square will be there. Hence, what will happen? Ts will be directly proportional to d square by 4. So, this will be the final expression. Okay, what does this mean? This means that just by changing the drainage condition from single to double, the time required will be minimized 4 times. Okay, it will be minimized 4 times, you can see. Means if example we can say a layer was taking, let us say 4-hour time, okay, when it was single drainage, then once we change it to double draining, it will take only 1 hour time for double. Okay, I think you have understood this. So, the same thing is written, a half closed layer requires 4 times as much as time to consolidate than a open layer of the same thickness H, you have seen here. Besides, the solution can be used to view the progress of consolidation by plotting a series of curves of UE versus Z at different values of T. Okay. Such curves are called isochrone, and form depends on the drainage boundary condition and the initial distribution of UE and Z. Isochrone of an ideally constant UE versus Z distribution is shown here. You can see this is UE, which is constant, and you can see different TVs are made here. Okay. Different T is obtained here like this. okay, for constant u at different z, because z will be here nearly 2d, something 1.5d, d by 2 and all. So, for different z they have plotted the, you can see the curve to find the different isochrones, okay, something like this. Only u e is constant here. So, this is also a just a behavior, just shows the behavior of the u, okay, at different conditions according to the varying z. Now, average degree of consolidation. The degree of consolidation, what is degree of consolidation? That is u only, okay. This is expressed in percentage, we have already talked about it. This is only the degree of consolidation. Sorry. Degree of consolidation. Okay, this is called the degree of consolidation. The formula can be written as this, okay, u is 1 minus u upon delta u. Okay. Generally, we do not use this formula for this, because we generally use which formulas? Generally, the formula which we had also derived yesterday, such as delta h upon h. Okay. If you remember, we also derived a formula something like delta h upon h. Okay. Just multiply it by 100 to get the percentage of or degree of consolidation. Okay. Or you can also use the formula E naught minus E upon E naught minus E final. This will into 100 also will give you the same value of u only. Okay. So, these are also the formulas. Now, relating this T v time factor with u, okay, how are they related? Actually talking, T v will depend on u, we have already discussed about this. Now, how is this related? If value of u or u is less than or equal to 60%, okay. Remember this, if u is less than equal to 60%, then T v is calculated by the formula pi by 4 u square, okay. But remember, u here will be in fraction. So, you can also say that this can be said to be u must be less than equal to 0.6, okay. In this case only, up to this case only, less than equal to, T v will be calculated by this formula, okay, pi by 4 u square. Let us see for the 50% case, we already have done this, okay. For 50% case, what will it become? T v will be pi by 4 into 0.5 square. So, this will be nearly 0.198, okay. This will come out to be nearly 0.198. Then the next case, if u is now greater than 0.6, then what will happen? In this case, T v will be calculated by a long formula, which is 0.933 log of 1 minus u, okay. This is minus, remember here, and 1 minus u minus 0.085. This is the total formula, or we can write this here also, 0.85. So, this is the formula. If we put now, once the value of u exceeds 0.6, we have to use this formula to find out the value of T v, okay. So, for u 90%, what it will be? The same formula, just we have to put T v is equals to minus 0.933 log 1 minus 0.9 minus 0.085. Just calculate it, it will be nearly equal to 0.848. Okay. So, now you have understood how is T v and u related, what is u, what is T v and all. Okay. So, let us move further. Now OCR, what is OCR? It is the over consolidation ratio. Okay, this is the formula. Now what is this? What is this and what is this? Remember OCR, in short you can remember it, past upon present. Past upon present, okay, means this is the pre-consolidation stress, okay, and this is the present applied stress. This was already applied, okay, pre-consolidation, or previously you can say also it as past applied stress, means the highest one, not any one, the highest one, okay, the highest one or the highest stress applied in the past. This is that parameter, and this is the present, how much you are applying at the present. So the ratio of this will give you OCR. What is OCR? Over consolidation ratio. Now this is useful to find out whether the soil is normally consolidated or over consolidated. How? If the value of OCR comes out to be 1, let me clear it. If value of OCR comes out to be 1, it is called as normally consolidated soil. How? How? Because you will remember this is past upon present. So if OCR is 1, means past upon present, which means past is equal to present for this case, okay, past is equal to present, which means this is the highest stress which is ever applied to this soil. This is the highest stress which is ever applied to this soil. So it becomes normally consolidated soil, okay. But if OCR comes out to be greater than 1, OCR comes out to be greater than 1, then what does this mean? This means that this again past upon present. So this means past is greater than present, okay, past is greater than present, only then this ratio can come greater than 1, means that the present stress which you are applying is lesser than the load or stress which is it has already got used to in the past, okay. Means suppose in practical example, if you see, suppose there is some soil, you apply 10 kilonewton, okay, it will get stressed or it will get compressed, okay, to some extent. Now you remove this load, now only apply 1 kilonewton, okay, as it has already got used to 10 kilonewton, it won't be much affected by 1 kilonewton load, okay, it won't get much compressed by this 1 kilonewton load. So the ratio greater than 1, hence this is also a over consolidated clay only. So hence we can find that OCR, if it is greater than 1, then it is a over consolidated soil, okay. Now over consolidation is useful for used in due to the following factors. Erosion of the overburdened soil, means over consolidation, when does this occur? This occurs when there is the erosion of overburdened soil. We have already discussed about this, and the permanent lowering of water also, okay. Means overburden means suppose this is something like their ground, here some soil is there, okay, erosion of this soil takes place, some part of this erodes out, okay, some part of this erodes out, something like this, okay. Now we are only left with something like this, it was here, ground level was here, now it is here. So this much stress has relieved, so this now becomes the over consolidated soil. Similarly, in case of a water body, say if a water body is filled like this, okay, so first of all water will be also here, pore pressure will be exerted and all, okay. So it has a different pressure condition. Now if water reduces here, okay, water gets lowered, then this part gets freed, okay, this much part gets freed. So this part will remain as over consolidated, and this will be again under the normally consolidated only. Okay. So, this was it. Now, let us go and see some of the numericals. Okay. We have discussed a lot of things about Terzaghi's theory and all, CV and MV and all. Let us put it into the use. So, first of all, let us see the question, study the question properly. In a laboratory consolidation test, the void ratio of the samples reduced from this 0.85 to this 0.73 as the pressure was increased from 1 to 2 kg per centimeter square. If the coefficient of permeability is this, okay, centimeter per second, determine what is this volume of coefficient of volume change MV and coefficient of consolidation CV. Okay. Two things are to be required. We are given with K. Okay. K is as 3.3 into 10 to the power minus 4 centimeter per second. Okay. 1 K is given to us. Stress increment is also given to us, which is 1. Okay. 1 kg per centimeter square. And what is the delta E? Delta E is also given to us, which is 0.85 minus 0.73, which is nearly 0.12. Let us first diagrammatically understand this. See, the load is being applied here. Okay, the load is being applied here before also, means this was initial condition of the soil. After that, load increment is done. This you can see load increment has been done. Due to this load increment, this much void ratio has been decreased, or we can say this much of the void has reduced in this soil. Okay. So, this is the final E and this is the initial E. The difference will give you delta E, which we have already find out, and this is also given to us. So, now let us see. First of all, what we will do, one second. Okay. Just I think something is missing here. Okay. First of all, we will find out the coefficient of volume change MV. Okay. Find the value of MV. What was the formula for MV? Delta E upon 1 plus E naught into 1 upon delta sigma naught or delta sigma only. This we have already discussed just now, 0.83 minus 0.85 minus 0.73. Okay. And E naught is this obviously 0.85. Okay. And what about this? We had seen in the question that it was increased from 1 kg per centimeter square to 2 kg per centimeter square. So, what will be the difference? This is delta, means it is the difference. So, it will be 1 only. Just solve this part. So, just we put the values all and we get 0.065 into 10 to the power minus 3 kg per centimeter square per gram. Okay. This was the first part of the question. Okay. This is it. Now, we have done this. We are done with MV. Now, let us go to CV. For CV, what is CV? Just now we have written CV, MV, gamma W is given K. Okay. Value of K is given to us, if you remember. Gamma W we already know the standard value. This is all going on in gram and centimeters. So, value will be 1 only, 1 gram per centimeter cube. Okay. MV just now we have calculated how much it was, 0.065 into 10 to the power minus 3. Okay. So, we can find out the CV. What is the value of K given? That is 3.3 into 10 to the power minus 4. Just solve it out to get C. Okay. So, this is the answer. Okay. This is done. Okay. This was it for this presentation. Just go through the question on what is over consolidation ratio and CV and TV relationship. Next turn we will be discussing some more numericals on this consolidation chapter. Okay, so that you can get used to the formulas which we have derived or studied so far. Okay, keep watching the videos. Thank you.